Open OpenMathAI. In this demonstration, we use a battery SoC optimizer blueprint. Click Load Blueprint. Select a folder location to save the project. OpenMathAI automatically loads the required project files and settings. Navigate to the Import Data section. The example dataset is loaded automatically. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the linear regression model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Multimodal Training. Review the training configuration. Test data split, which determines the percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range, 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95, accuracy almost equal to 95%. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. ANSYS, FMU 2.0, FMU 3.0, Python Bundle, ONNX Hub. Select the destination folder for the exported files. In this demonstration, select ANSYS Engine. Click Deploy Engine. In the professional version, OpenMathAI can also generate PowerPoint and PDF reports. The exported engine folder contains source code, makefile, readme file, sample input files, open command prompt or terminal. Navigate to the exported model folder. Run the make command to compile the generated source code. The compilation process creates an executable file. The executable file name starts with test underscore followed by the model name. Run the executable file. You will receive the output corresponding to the first dataset sample. If required, you can edit and customize the generated source code. We also verify the exported model on a Raspberry Pi. Open the PuTTY application on Windows. Enter the Raspberry Pi IP address and click Open. When prompted, enter the Raspberry Pi username and password to establish the connection. After logging in, you will get remote terminal access to the Raspberry Pi. Next, transfer the exported model folder from Windows to the Raspberry Pi using the SCP, Secure Copy Protocol. Before transferring the files, delete the Windows executable file generated during compilation because Windows executables cannot run on Linux. Open Command Prompt on Windows and use the following command: scp-r, folder name Raspberry Pi, username, @Raspberry Pi, IP, destination folder. Press Enter and provide the Raspberry Pi password if requested. The model folder and all associated files will be copied to the Raspberry Pi. Return to the PuTTY terminal and navigate to the transferred folder. CD folder name. Compile the source code using the make file. Make file. This creates a Linux-compatible executable file. The execution process is identical to Windows, only the compilation step differs because Linux generates a different executable format. To run the executable, use Test Linear Regression. Press Enter to execute the model. The program processes a sample input data and displays the predicted output values. The generated source code remains fully editable and can be modified, recompiled, and redeployed on the Raspberry Pi as needed. This confirms that the exported OpenMathAI engine can be successfully compiled and executed on both Windows and Linux-based Raspberry Pi systems.